Assalamu alaikum wa rahmatullah. Today, inshallah, we're gonna explain the plotting part in the previous reports, inshallah. The first plotting was about the absorbance this wavelength. How we were gonna do it? Basically, first we were gonna select the we have a different samples with different concentration. We were gonna select the column which contain the wavelength and the absorbance for the first sample, which is 20 ppm. After that, we will gonna go to the scatter and press the third one. Okay, we're gonna have this graph. How to add another data to this graph? Basically, select the right click and then go to the selected data. After that, go to add, press add, and the series name. Just write the sample name, which is 15 ppm. The x-axis, which is the wavelength. Select the x-axis. You can select it manually like this, or basically write the index of it, like in the y-axis. We need the absorbance. By absorbance is h and 3 to the h to 1, 2, 3. Or you can select it manually like this. Then press OK. Also, we have another data. Add 10 ppm. X the wavelength. And the y-axis is the absorbance of the 10. Okay, and then add the other sample, which is 5 ppm. X-axis, we have this column. And the y-axis is the absorbance for the 5 ppm. And then select or press OK. Add the sample 2 ppm. X-axis, we have the wavelength of the 2 ppm. The y-axis press OK. We need to add x-axis the wavelength. Y-axis is the absorbance. Okay, the last sample, which is the unknown one. Press add. Let's call it x ppm. X-axis the wavelength. Y-axis is the absorbance, the unknown sample. Okay, now we add all the series of the data. Just click OK, then it will gonna be added on the graph. Okay, now we need to make it more scientific way. First, we need to remove these lines. select it and then press right click, format axis. Oh no. Right click, format axis. Divide. Oh no. No line. Also, we don't need line. The plot, we need to add a square around it, format plot area, and then we need in the border, we need a solid line. Let's make it 0.25. Okay. In the y-axis, as you can see here, it starts from minus 0.2. We need to let it start from 0. How? Click the axis and then format axis. In the minimum, just delete the 0.2 and click 0. And in the x-axis, we need to select the range, which is the range of the UVs, which is from 200 till 800. Okay. Now what we need to remove the title of the plot. Access title. Okay. Feature title, we don't need it. We need to add the title for the axis. The axis, what we have the wavelengths. Nanometer. And in the y-axis, we have the absorbance, which is unitless. Okay, this is the first plot. You can like add the legend for like to let the reader know what what each line represents. Okay, you can adjust the font and the size of the font. Here, series 1, you can it is 20 bpm. We can select data and then edit. We need to name it 20 bpm. Okay. Now the first plot is ready. Okay, let's go to the second plot, which is the absorbance with concentration. The concentration, basically, we have it, which is the 20 ppm, 10 ppm, 15 ppm, etc. The absorbance, we need to find out the absorbance for each concentration in the highest wavelengths, okay, and the max wavelengths. But first, we need to find out the highest absorption, which is we needed to find out the highest wavelengths. Okay, the highest absorption from where we can find it. Basically, we have a function in the Excel, which is the max function. We can use it to find the max value in this column, in the B column, which is start from B3 and end with the last cell, which is B123. Okay, okay. Equal max B3 till B123. Okay. The wavelength max, we can use this function to find out the highest wavelengths. Okay, let's explain what is the function says. It is like we tell the function is the value here, which is the highest absorption. It is located in the range, which is the column B. 0, don't change this value, يعني specific research about this value, and then match it with the column that we need to take the corresponding cell with it. Like if the highest absorption is here, we need to take the highest wavelength, يعني the highest wavelength, let's imagine it is 779, okay? I will put the function, the value of the highest absorption, and I will need from here, from it to find out the highest wavelength, which is corresponding here. Okay, same thing with which we will gonna do here. Okay, the value here, which is will gonna be the highest absorption, we can enter the value as it is, like 1.4644, etc. Or basically you can enter the function itself, which is the max B3 till B123. Okay, and find it in the range, which is the column B. Same thing, B3 till B123. 0 here basically is function to tell the code don't change this value, like take it as it is, don't change any points, and you find out the same value as it is. يعني حتى لو كان في missing one value, like B2 wasn't there, it will not take it. Match it with the range, which is I need to search in it, or I need to take its value, which is the wavelength A. Okay, it starts from A3 and end A3 till same thing A123. Okay, it gives me that the highest wavelength is 49499.2, etc. Okay. Okay, now we can find out the highest absorption at lambda max for each concentration. Okay, I already applied here, but I will gonna do with you with the concentration 15. Okay. Okay, the value here, which is this one, we can enter it as it is, which is 494.992218. And in the range, here the wavelength, and the range of what? 15, the wavelength where it's located in the G column, right? So G 3 till G 1 2 3. اوكي طيب بعد كده ندخل range اللي we need to search on it, which is H column H3 till H1 2 1 2 3. We forget the equal sign. Okay, we can do the same thing with the 10. Here the 10, it's located in the wavelength that's located in the eye. The absorption, which is correspond to the highest wavelength, it's located in the J column. Okay, and it's what gonna leave. Okay, we can do the same thing for 5, which is the wavelength in the K. And the absorption, which is in the L. Or you can select this manually as we did in the first plot. Okay, here with the 2, it's located the wavelength in the N column. And we need to search in N column. Here, M column and N column. Yeah. The first one, which is the concentration 1, O1. Okay. The wavelength in O. And we need to search in B column. Okay. Now we find out the concentration and its corresponding absorbance at the maximum wavelength. We can now load the data, insert. As you can see here, it's a linear. First, we need to add the trend line, and we need to display the equation. Okay, from the equation we can know or find out the unknown concentration. Okay. طيب to enhance this graph, same as we did in the first one, and same as we did in the first and the previous reports in the class. Okay, I will not do it now. The third one, which is the talk plot, it's basically we need to find some variables before we upload it, which is the energy and the absorption coefficient alpha, and then we multiply them together and find out the square. Why square? Because in the report it tells us like to assume it is direct. If it was indirect, we will change the square to like to square root. Yes, to square root or to the power half. Okay. Okay, to find out the photon energy, it is written in the yeah, it is written here. Take just the 1240 and divided by the wavelength. Okay, equal. It was 1240 and divided by the wavelength, which is located in A3. Okay, this is the corresponding photon energy. Double click, it will do it for the other columns. Absorption coefficient, it's basically, it's written also in the lab manual, which is 2.303 multiplying by the absorption divided by the which is the path distance, which is 1 centimeter basically. So you don't need to divide here. Just take 2.303 multiplied by the absorbance. Okay, it's equal to it was 303 and multiplied by the absorbance, which is located in the B3. Okay. Double click, it will gonna do it for the others. Okay, and here no, let it. Okay. Here we need to multiply the C and D column equal C3 multiplying by D3. Okay, double click to do it for the other. Here we need to take the square root of the E column equal E3 square root or square. Yes, square, not square root. Huh? Okay, here as you can see, it is E. like the format of the inserting the number, it's wrong. So we need to change the format to the number. Okay. طيب. To plot the Tokyo plot, we need two things, which is the photon energy. It will gonna be in the x-axis. The column F, it will gonna be on the y-axis. Okay. Let's select the energy column. And also, let's select this column. And we need to insert scatter plot. Okay. This is a plot that you will gonna find out. Okay. Okay. Okay, let's keep it here. What he need from you to find the EG. Okay. Yes. To find the EG. Basically, we're gonna find out the range of the first peak, and then we will gonna plot the line to correspond this with the x-axis to find out the value of the EG. Okay. The bend energy. Okay. This is the first peak. We need to take this just the first peak. We will gonna first we will gonna select the y-axis. We need to start from 0 and let's take it to the 100 just. Okay. After that, we need to select the x-axis and take its range. Format x-axis. We needed to start like from 2.1 till approximately 2.5. Okay, as you can see here, let's represent the first week. Okay. We can draw a line, or let's take it two point zero till 2.6, for example. Okay, this is more clear. Okay, we need to find a line or draw a line, and we need to get like accurate data. We need to have like 0.1. Let's take it 0.1. Okay, and we need to draw a line which match this slope and find out the value of the each. Okay. It will gonna be approximately like 2.2 something. To find a specific value, we can the x-axis 0. Take it 0.5. Same thing. Okay. Okay, approximately 2.22 approximately. Yeah, EG is 2.2. And same thing, the enhancement or the format of the plot, I will not gonna do it. It's same as what we did in the first plot. Okay, thank you. I hope it was helpful. If you have any question, you can send me.